What's up, everybody? Welcome. Thank you for being here and checking in. We're on page 432 for this video. We're starting a new activity. So some new information, like launching new information for you is incoming. Chords and arcs. In this activity, you will investigate the relationships among central angles and their intercepted arcs. For a reminder, make sure that mathematicians, people learning how to be successful in mathematics, think mathematically, argue completely, they're doing these things. So in this lesson, we're going to be talking about how you are reasoning abstractly and quantitatively, and how you are constructing viable arguments and critiquing the reasoning of others. Those are the two things that we need to make sure that you can do, or you're continuing to build on. How are you going to reason abstractly, and how are you going to construct an argument throughout the process of this video? Now, the color wheel is made of three different kinds of colors. Oh my gosh, bring in some art. I love it. Primary, secondary, and tertiary. And those, you see what I did there? Okay. Primary colors are red, blue, and yellow, and are the colors that you start with. So then you create secondary colors like oranges, greens, and purples, which I actually think this is a little out of sync with the way they listed red, blue, and yellow. Shame on them. Those are created by mixing two primary colors. Red and yellow make what? Red and yellow make what? Okay. You create tertiary colors, so these are mixtures of the mixtures, by mixing in a primary color with a secondary color. And I must also emphasize that you put the primary first. That's how you list the sort of color that you have created. You put primary first and then secondary. There's no such thing as an orange-yellow. It's a yellow-orange. Now, the circle C is shown, and there are points on the circle equidistant from each other. Did you know color theory is a set of rules that are used to create color combinations, and therefore a color wheel is a visual representation of color theory? Yeah, that's a fact. That's something that you could do for your, maybe if you're like paying attention in art class, you've seen this and heard about this, and now you need to know that it's all connected to math. Boom, got them. Now, we're gonna draw two congruent chords using any of the adjacent positions on the circle as endpoints. The word adjacent means next to. So when we're drawing our two circles, we're looking, or two congruent chords, we're looking for chords that are next to adjacent points as endpoints. So I'm gonna connect a line from, let's go from green to blue. I'm gonna connect a line, I guess I'm gonna use black. Let me check the size of this marker thing. Let's go down to here. I'm gonna connect green to blue in this one. So green to blue. There's a chord right there. It can be a little more precise. Let's see, a little more precision. Pretty decent right there, okay? So that's a chord. And you might have connected that one, and maybe you're gonna connect different ones. I wanna connect a different one though. I don't want it to be like a bow tie, because what we're gonna create are lines. I'm gonna connect yellow to orange. You connect whatever you want. I'm connecting green and blue, and then I'm gonna connect yellow to orange. And I need to make sure my precision is there, so something like that. Something like, slip it in. Pretty happy with that, pretty okay with that, all right? Now, next up, draw 4 radii by connecting the endpoints of those chords with the center point of the circle. So I'm gonna use, let's use red for my radii, and I want my line, it looks good, here we go. So I'm gonna connect the center. Whoa, do you know how to find the center of a circle? They don't have a point listed right there. This is something that we need to make sure is emphasized from before. When you don't have a center of a circle, if you take tracing paper and you trace that line segment and then fold that line segment in half in a certain, like line up the endpoints and crease it, that crease is the perpendicular bisector. We need a perpendicular bisector of that line, something that looks about like, because I don't see a dot in mine. Do you have a dot in yours? I don't think you do. Okay, so I'm gonna draw my this is me eyeballing, by the way. You should do the actual technique of the trace it, fold it in half, trace that tracing line. Go something like that, 90 degree. It's not in the middle. I feel pretty confident that that's the middle. By drawing perpendicular bisectors of chords, when those perpendicular bisectors cross, you get the center of the circle. So I'm doing that right now. I don't know where the center of the circle is. There's just a letter C. I didn't realize that until I started this thing. Here we go. So drawing a line. Trying to get my 90 degree first on this digital tool. That looks about like 90, maybe a little bit off, maybe like that. I, of course, could take something that is 90 degrees and just see if it lines up. That lines up pretty evenly. Yeah, pretty okay. It might be like 89 degrees and not 90, but it's close enough to do damage. So here we go. Oops, not you. I need to now select my line and get it to the middle. About like that. That looks about the center of the circle, don't you think? It's where the two chords cross. Okay, now I'm ready to do the task of the day. And that is draw 4 radii from the center of the circle out to those end points of our chords. I'm gonna draw CO, I'm gonna draw CY, I'm gonna draw GC, I'm gonna draw BC. Now that I've done that, I don't need my green lines, so I'm gonna go ahead and erase them, okay? I'm gonna click on you and delete, click on you and delete. There we go, I've got my center of the circle and I've got my points going to it. Okay, oops, don't see that yet. Let's make a conjecture about the central angle formed by the two intercepting minor arcs, about the two central angles and the two intercepting minor arcs. And so let's take a look out here. Let's just kind of analyze and bring in a little highlight here. The picture that we're given, go with yellow, this central angle, GCB, and this central angle, they look to be about the same. In fact, they should be the same because OY, GB, those points are evenly spaced. They're equidistant around the center of the circle. They're evenly spaced all the way around. So like a pizza that's been cut into 6 slices. These 6 slices, or in this case, I've got 2 right here. They're going to be the same size because the way that we cut them, the way we drew those lines and drew them out to evenly spaced lines tells us that they're going to be the same length. Follow that up with the arc out here. Arc OY and arc GB. Do you think those two arcs are different in size from each other? They should be the same. That's the final statement of this whole thing. Make a conjecture about the two central angles and the two inscribed or intercepted arcs, minor arcs, formed by each pair of radii. Well, the two central angles formed by each pair of arcs, they appear to be congruent. And since they appear to be congruent, that's the central angles. That's the yellow that I'm talking about. Boom. What a horrible noise. Okay. Shutter. That means that the minor arcs associated with those central angles must also be congruent. You know we're about to prove this thing, but at least for the while we have this as access. It appears that when two chords of the same circle or congruent circles are congruent, their corresponding arcs are also congruent. We're going to prove this conjecture in the next page. Here's a question for you. How do you know the chords are congruent? What are the names of the central angles associated with each chord? What are the names of the arcs associated with each chord? We should be able to identify that. The central angle, like I mentioned up here, would be like GCB, for instance, but its arc is GB, referencing central angle and intercepted arc. In this situation, did the chords determine the arcs or did the arcs determine the chords? And why do you think it's one way versus the other? I think actually the arcs determine the chords because when we did the positioning of the points along the circle, I think we used the fact that we're cutting a circle into even sections, and the way we cut a circle is with other circles, so you're using other arcs. Ooh, maybe I've convinced myself it's the other way around. The chords made the arcs. Something to think about. Thank you for watching this video. Like, comment, and subscribe. Page 433 is next. See you in that video. You're awesome.